Hey guys, how you doing? This is Renan with Piece of Pie Learning, and today I'm going to introduce to you what a system of linear equations is. So the first thing you have to understand is what a system of equations is. And simply put, it's just when you have more than one equation, right? So in the four examples that I have here, there's two equations. But don't get it twisted. You can have 3, 4, 5, 6, 7, an infinite amount of equations, and that's considered a system. Now, a system of linear equations is specifically when all of your equations are straight lines, right? In the word linear, you have line, opposed to a system of nonlinear equations, which would then be something like having a parabola with a straight line, or maybe a circle with a straight line, or you could have a parabola with a circle, etc., right? The main point being that when it's a nonlinear systems, one of the equations isn't a straight line. All right, so now that we got that out of the way, right? A linear system, many equations, they're all straight lines. The next thing you have to understand is what a solution to a system of equations is. And graphically, it's their point of intersection, right? On a graph, it's their point of intersection. And that's super important on the SAT because they won't say the word, or they won't ask you what's the solution. A lot of times they'll just ask you what's the point of intersection. And you have to realize that they're asking you for the solution. So here, for example, the point of intersection is 6, 3. Here, it's -3, -1. Before I move to the bottom examples, let me show you something real quick. So on this example, 6 being x, and 3 being y, you'll notice that it satisfies both equations. Now what I mean by that, 6 plus 3, right? 6 is x, 3 is y, equals 9. Yeah, it does. 6 minus 3 equals 3. Yep, that's true. Right, so this point satisfies both equations. It's a solution to both equations, and therefore it lies on both lines, their point of intersection. Same thing is true here. Right, if you plug in y for -1 for y, and then x for -3 on the bottom equation, right, you get that -1 is equal to -6 plus 5. That's true. Same thing on the other equation on top. -1 is equal to -2 over 3 times -3 minus 3, right? This is going to give you 2 minus 3, which is -1 as well. So again, the solution, their point of intersection, satisfies both equations. Now, the two bottom examples are special cases. The one on the left, right, you can clearly see there's no point of intersection. The reason for that is because they're parallel. Parallel lines will always have no solution. Remember that. Parallel lines, no solution. It's extremely important for this test. Without the graph, you can tell that they're parallel based on their slope. Right here, the slope is 2, and so is that one. And they have different y-intercepts. If you're still confused about slope and y-intercept, y equals mx plus b, please refer to my other video on linear functions where I break this down in depth. So for this video, just quick understanding that they're parallel, different y-intercept, therefore they never intersect, right? No solution. This last example, which just looks like one line, is actually two lines, right? But it's the same line. So imagine if you just had the same line, just one on top of the other. And if I ask you how many times does the same line intersect itself, I'd hope that you would say always, right? These two lines being the same always intersect, so we're going to say that it has an infinite, man, Lord, I need to work on this, guys. It's all good though. Infinite number of solutions. And real quick, if you want to be able to better see that these are the same line, just turn both equations into y equals mx plus b format. For the top equation, all you have to do is subtract 3x over, right? And that becomes y is equal to -3x plus 1. They're the same, right? So recap, a system of linear equations is many equations that are straight lines. The solution to a system of linear equations, or to a system of equations in general, is the point of intersection. If they don't intersect, no solution. If they always intersect, infinite solution. And that's basically all you got to know for the introduction. Tune in to the next few videos where I show you how to solve for the solution algebraically. Peace.